10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff.
Beginning pitch off.
Stage 1 propulsion nominal.
Okay, the lightning god's reign has begun and we are on our way to space. Electron has lifted off from Launch Complex 1, cleared the pad, and is now travelling at over 800 kilometres per hour as it propels iQPS's satellite towards orbit. Now, one of the next calls you'll hear from our operators is max Q, and that's the point in flight when Electron experiences the highest aerodynamic loads. Let's listen in for that call.
Cleared max Q.
That's max Q behind us, and Electron is continuing its way to space for our 61st mission. Electron is now at an altitude above 17 kilometers, traveling at speeds past 2,400 kilometers per hour. Up next, in quick succession, we have MECO, that's main engine cutoff, which is when the first stage engines shut down. A few seconds later, Electron's first and second stages separate. At this point, Stage 1's role in the mission is now complete. But it's just getting started for Stage 2.
Shortly after separation, the single Rutherford engine on Stage 2 will ignite, and that will propel us the rest of the way to an elliptical transfer orbit. So watch closely to see all of this take place in the next few seconds.
Stage 1 propulsion holding nominal. Stand by for MECO in 30 seconds.
"15 seconds to staging. Enter burnout detect mode.
MECO confirmed.
Stage separation confirmed.
Stage 2 ignition confirmed.
And as planned, that sequence of milestones is now complete, and Electron's second stage is continuing to orbit. Now it's the fairing's turn. The two halves of the clamshell fairing will separate and fall back to Earth, exposing the iQPS satellite to space for the very first time. Those fairings, like the rest of Electron's structure, are made from carbon composite, so they're incredibly lightweight but also strong. It's why we're making Neutron's fairings from the same material. But unlike today's fairings, neutrons will stay attached to the vehicle for landing and rapid reuse.
Fairing jettison confirmed.
And there we have it. Electron's fairing has been jettisoned, and the QPS-SAR-9 now has its unobstructed view of its new home in space. We are now coming up to 4 minutes into the flight with less than just a couple more minutes remaining in this second stage burn.
Guidance is nominal.
When it comes to launching rockets and spacecraft, we don't just build, then fly. We rely on rigorous test campaigns to ensure mission success. For new parts, we start with development testing, followed by design qualification, or qual. Qual testing stresses the design far beyond expected conditions it would endure for a nominal mission, with vibration, shock, thermal cycling, and thermal vacuum, or TVAC, being a handful of test examples conducted. Next up is acceptance testing, intended for real flight article hardware. These tests are typically less harsh on components versus qual as to not fatigue them. After all, these are being used on actual mission. The aim is to catch workmanship issues and performance variances. For Neutron, some Electron components are reused but require additional testing due to the high acoustic and vibration levels from the more powerful Archimedes engines. The scope of Neutron's test campaigns cover individual components in isolation up to large integrated tests to ensure various systems, avionics, software, mechanical fluids, propulsion all work together as expected. That includes tank pressure tests, engine hot fires, and as shown earlier, the Hungry Hippo.
All right, back to the mission you see on your screen. And next, we are getting ready to hear some of our 4 favourite words: battery hot swap successful. And that will mean that we have reached the point in flight when the depleted batteries that power Rutherford's electric fuel pumps are ejected from the second stage. We then immediately swap over to a fresh set of batteries to get us to the rest of the way to orbit. And that's why we call it a hot swap, since it happens while the engine burn is still underway. So as well as hearing the call out from operators, you should also be able to see the shiny silver batteries fall away from Electron on your screen. So eyes and ears at the ready for that flight milestone.
AGB discharge holding nominal, approaching hot swap in roughly 30 seconds.
Throttling down. Battery jettison confirmed.
Confirmed delta successful.
Stage.
Okay, in the eternal words of InSync, we have said bye to those batteries. A fresh set has taken over with just a few minutes now remaining in the flight. And the average orbital Electron mission takes around 9 minutes to reach orbit, which means across more than 60 missions, we have spent more than 9 hours capturing views like this one on our multiple journeys to space. And still, I tell you what, it's a view we never get sick of.
With just over 7 minutes completed in today's launch, we have passed through most of the key milestones with just 2 more remaining. That's SECO, or second engine cutoff, and stage separation. This is where Electron's kick stage separates from stage 2 in preparation for payload deployment. But before that, we've still got a few minutes to watch that Electron's nozzle glow brightly before shutdown.
Okay, T plus 7 minutes, 47 seconds and counting, and everything is proceeding nominally so far. The operators in mission control continue to monitor vehicle systems closely as we approach that all-important throttle down and the second engine cutoff ahead of kick stage separation. Now, if you're keeping an eye on our speed, you want to see that dial at around 27 to 28,000 kilometers an hour, which will indicate that we have hit orbital insertion speed.
AGB discharge holding nominal.
Electron's 61st flight is coming to an end in just a few moments. We're now expecting to hear the call out, burnout detect mode, from mission control. Once we hear that call, you'll know that second stage shutdown is close.
20 seconds remaining.
SECO confirmed.
Nominal transfer orbit achieved. Stage separation confirmed.